What if some landscapes on Earth were so strange, so visually unreal, that if they appeared in a film, we would assume they had been invented rather than found? Across the planet, far from the places most people ever think to look, nature has spent ages shaping environments whose color, scale, and movement seem to challenge the very idea of what a real landscape is supposed to be. At Hukou Waterfall, the Yellow River is suddenly forced through a narrow stone passage, compressing enormous power into a violent surge of water that erupts into thunder, mist, and constant motion, as if the land itself is struggling to contain it. In Haidushan, the world turns darker and stranger, where mineral-stained slopes ripple across the ground like waves held in place, creating a stark, otherworldly terrain that feels less like a corner of China and more like the surface of an unfamiliar planet. And in the surreal expanse of Dachindan Jinan Lake, mineral-rich water spreads slowly across the basin in vivid colors and intricate patterns, forming a landscape so unusual that it seems less created by geology than painted by it over centuries of silence. How can natural forces shape places that look so far removed from the world we think we know? And if landscapes like these already exist in plain sight, how many more remain beyond the familiar horizon, waiting for the right light, the right season, or the right moment to be seen at all? Somewhere beyond the maps we think we understand, places like these are still waiting, quietly, improbably, and beautifully, ready to remind us that this planet is far stranger than it first appears. Haidushan. In the remote highlands of Qinghai Province, Haidushan reveals a landscape so stark and unfamiliar that, from a distance, the ground appears less like solid terrain and more like a frozen ocean of dark waves spreading across a plateau. The surface is dominated by deep black volcanic rock, whose flowing contours and layered textures resemble currents of liquid stone that once moved across the land before suddenly solidifying in place. These formations originate from ancient basaltic lava flows that spread across the region during periods of volcanic activity, where differences in cooling rates, viscosity, and movement within the molten rock created gentle ridges and folds that remain preserved in the hardened surface today. Over immense spans of time, wind erosion and seasonal weathering gradually stripped away loose sediment that once covered the area, slowly exposing the underlying volcanic patterns that now define the terrain. Unlike colorful mineral landscapes shaped by chemical deposition, the visual impact of Haidushan comes primarily from the interaction between light and texture, as the dark basalt absorbs most sunlight and creates a subdued palette that accentuates the subtle curvature of the rock formations. When sunlight strikes the slopes at a low angle, faint highlights trace the undulating lines of the basalt surface, strengthening the illusion that the ground once behaved like a fluid that later hardened into its present form. The surrounding environment intensifies this effect, since the high-altitude plateau supports very little vegetation, leaving the volcanic structures largely exposed across wide stretches of land. With few visual distractions, even small variations in slope, fracture, or mineral tone become strikingly visible, allowing the wave-like formations to dominate the landscape. As a result, Haidushan feels less like a typical mountain environment and more like a geological memory of motion, where ancient lava flows have been preserved with such clarity that the Earth itself appears to have paused mid-movement, leaving behind a terrain that seems closer to the surface of another planet than to any familiar landscape on our own. Dachaiden Emerald Lake. In the remote expanses of the Kaidam Basin in Qinghai Province, Dachaiden Emerald Lake unfolds as a landscape of striking mineral pools whose vivid colors spread across the desert floor like fragments of glass scattered over pale earth. From above, the water appears in shades of turquoise, jade, and deep emerald, forming irregular shapes that contrast sharply with the surrounding salt flats and arid terrain. The unusual coloration of these lakes is the result of mineral-rich groundwater interacting with high concentrations of dissolved salts and trace elements within the basin. As water accumulates in shallow depressions and slowly evaporates under intense sunlight, minerals such as magnesium salts and other compounds become increasingly concentrated, altering the way light reflects from the water's surface. Because each pool contains slightly different chemical compositions and depths, the colors vary dramatically from one section to another, producing a patchwork of tones that can shift depending on sunlight angle and seasonal water levels. In certain conditions, the lakes appear almost luminous against the stark desert background, reinforcing the impression of a landscape that seems painted rather than naturally formed. Geologically, the Kaidam Basin functions as a large inland drainage system where water flowing from surrounding mountains collects but cannot escape to the ocean, allowing salts and minerals to accumulate over long periods of time. This slow concentration process gradually transforms ordinary water bodies into chemically distinct pools that mirror the geological history of the region. What makes Dachaiden's mineral lakes so visually surreal is the contrast between simplicity and complexity, where a seemingly empty desert suddenly reveals a network of intensely colored waters shaped by evaporation, mineral chemistry, and time. In this quiet basin, natural forces have arranged color, light, and geology into a landscape that appears almost otherworldly while remaining entirely the product of Earth's own processes. Hitachi Seaside Park. Stretching along the Pacific coastline in Ibaraki Prefecture, Hitachi Seaside Park occupies a broad landscape of gently undulating hills, where seasonal vegetation transforms the terrain into sweeping bands of color that appear almost painted across the ground. From elevated viewpoints, the hills seem to dissolve into flowing patterns of flowers that follow the natural contours of the land, creating the impression of waves rolling slowly across the surface. One of the park's most iconic spectacles occurs in spring, when millions of delicate blue Nemophila blossoms open simultaneously across the slopes, forming a dense carpet of pale, sky-colored petals that stretches uninterrupted over entire hillsides. Because these plants grow low to the ground and bloom in tightly clustered formations, the individual flowers blend together visually, producing a continuous surface of color that resembles a soft blue sea spreading across the landscape. Under clear weather conditions, the visual effect becomes even more striking, as the blue of the flowers gradually merges with the color of the sky above, making the boundary between earth and horizon appear almost indistinguishable from a distance. Gentle coastal winds move through the fields in subtle currents, causing the blossoms to sway in waves that reinforce the illusion of a living, shifting surface. The dramatic scenery is not simply the result of wild vegetation, but also of deliberate landscape planning that organizes different plant species across designated sections of the park in order to highlight seasonal change. This approach allows the same terrain to transform dramatically throughout the year as different species bloom in succession. In early autumn, for example, large fields of kochia shrubs gradually shift from bright green to deep crimson, turning the once blue hills into rolling waves of red vegetation that extend across the same slopes. As sunlight moves across the terrain, the rounded forms of the shrubs cast soft shadows that enhance the texture of the fields and emphasize the layered structure of the landscape. What makes Hitachi Seaside Park remarkable is the scale at which botanical growth patterns can redefine an entire environment, where millions of individual plants collectively transform hills, color, and perspective into a scene that feels almost surreal in its simplicity. In this setting, natural growth cycles and human landscape design work together to produce a seasonal panorama that appears less like a traditional garden and more like a vast, living canvas shaped by time and light. Huko Waterfall. Along the middle reaches of the Yellow River, Huko Waterfall marks a dramatic point where one of Asia's longest rivers is abruptly forced through a narrow stone channel carved into the Loess Plateau. As the broad current converges into this confined passage, the immense volume of water compresses violently, surging forward with explosive force before plunging into the basin below. From a distance, the scene resembles a river struggling to escape its own boundaries, as torrents of sediment-heavy water crash through the rock corridor and erupt outward in thick clouds of spray. The Yellow River carries enormous quantities of silt from the plateau upstream, giving the water its dense ochre color and amplifying the visual power of the cascade as it collides with the canyon walls. Unlike taller waterfalls, shaped primarily by vertical drop, Hukou intensity comes from hydraulic compression. The river narrows dramatically before reaching the fall, concentrating energy into a short but extremely turbulent descent that produces a continuous roar echoing across the surrounding cliffs. During high flow periods, the river's force intensifies further, sending plumes of mist and foam upward from the impact zone and filling the canyon with a constant haze of moving water. In winter, the surrounding spray can freeze along the rock edges, forming temporary curtains of ice that frame the rushing current beneath. What makes Hukou Waterfall so striking is not simply its height, but the raw energy of a massive river momentarily confined by geology. For a brief stretch of canyon, the Yellow River appears almost too powerful for the landscape containing it, revealing how the interaction between water, sediment, and rock can transform a simple river passage into one of the most dramatic hydrological scenes in China. Akin Spring. Set within the remote desert landscapes of Qinghai Province, Akin Spring appears at first glance like a strange eye embedded in the earth, its circular pools of deep turquoise and crimson spreading outward across the barren ground. From above, the mineral-stained basin resembles a giant pupil surrounded by concentric rings of color, creating a visual pattern so unusual that the site is often described as the eye of the earth. The formation is created by geothermal activity beneath the surface, where heated groundwater rises through fractures in the surrounding rock and reaches the open air through a series of small vents and springs. As this mineral-rich water emerges and spreads across the surface, dissolved elements react with oxygen and sunlight, gradually depositing pigments that stain the surrounding sediments in vivid shades of red, yellow, and green. Over time, the continuous flow of water reshapes the basin into shallow pools connected by narrow channels, while evaporation and mineral accumulation reinforce the circular outlines that give the spring its distinctive appearance. Because the region lies within an arid plateau environment, vegetation remains sparse, leaving the colorful mineral formations sharply exposed against the otherwise muted desert terrain. What makes Aiken Springs so striking is the contrast between the simplicity of the surrounding landscape and the intricate patterns created by geothermal chemistry, where underground heat, groundwater movement, and mineral reactions combine to produce a scene that feels almost biological in form. Seen from above, the desert appears to open briefly into a vivid eye of color, revealing the hidden activity of the earth beneath an otherwise quiet surface. Anlong Pyramid. Rising from the rural landscapes of Guizhou Province, Anlong Pyramid appears at first glance like an enormous geometric structure standing alone among fields and low hills. Its sharply sloped sides a near symmetrical outline, giving the impression of an ancient monument rather than a natural landform. From a distance, the formation resembles a colossal pyramid emerging from the earth, with steep, triangular faces that converge toward a flattened summit. Despite its striking resemblance to a constructed structure, the formation is believed to be the product of long-term geological processes acting on layered sedimentary rock within the region. Over extended periods of erosion, wind, rainfall, and surface runoff gradually wore away softer surrounding materials while leaving the more resistant rock layers intact, slowly isolating the steep-sided hill that now dominates the landscape. The relatively uniform slopes of the formation are the result of differential erosion along natural bedding planes, where rock layers with slightly different resistance to weathering guided the shape of the hill as surrounding terrain was lowered. As erosion continued, the remaining mass preserved a remarkably regular geometry that strongly contrasts with the irregular hills typical of the surrounding region. Because the structure stands in relative isolation on otherwise gentle terrain, its geometric appearance becomes even more pronounced when viewed from a distance, reinforcing the illusion that the hill might have been deliberately shaped. In reality, the pyramid is simply an example of how geological layering and long-term erosion can occasionally produce forms that mimic the symmetry and precision normally associated with human construction. Vinicunca. High in the Andes of southern Peru, Vinicunca rises above the surrounding valleys as a striking ridge where vivid bands of color sweep across the slopes in layered waves that appear almost impossibly precise for a natural formation. From a distance, the mountain seems painted across the horizon with deep red, golden yellow, pale green, and violet tones stretching horizontally along the ridgeline, as if the landscape itself had been brushed with color. These striking patterns originate from ancient sediment layers that formed millions of years ago when mineral-rich sands and clays accumulated across the region long before the Andes Mountains began to rise. As powerful tectonic forces gradually pushed the land upward, those once horizontal layers tilted and emerged above the surface, revealing the mineral compositions that had remained buried deep within the earth for immense geological timescales. Iron-rich sediments oxidized over time to produce the intense red tones visible across large portions of the mountain, while other minerals containing sulfur and copper compounds contributed bands of yellow and green that appear between the darker layers. Over thousands of years, wind erosion and seasonal meltwater gradually stripped away the soil that once covered the ridge, exposing the colored strata more clearly and sharpening the boundaries between each geological layer. Unlike many mountain environments, where vegetation softens the appearance of the rock, the high altitude and harsh climate surrounding the ridge limit plant growth and leave the mineral bands largely exposed across the slopes. What appears surreal at first glance is simply the visible record of millions of years of sedimentation, tectonic uplift, and erosion combining to create one of the most extraordinary natural landscapes on Earth. On the western outskirts of Kyoto, Arashiyama Bamboo Grove forms one of Japan's most recognizable natural landscapes, where towering bamboo stalks rise in dense vertical lines and create a forest unlike any typical woodland. As visitors step into the grove, the scene quickly transforms into a corridor of tall green columns, with slender trunks stretching upward and filtering sunlight into soft patterns across the path below. Unlike ordinary trees, bamboo grows in long, hollow stems that can reach impressive heights while remaining relatively thin, allowing large numbers of plants to stand closely together without blocking one another's access to light. The result is a forest where vertical rhythm dominates the scenery, giving the grove an architectural quality that feels almost carefully constructed rather than naturally grown. Wind moving through the grove produces a distinct sound as the tall stalks sway and brush gently against one another, creating a soft rustling that has become one of the defining sensory elements of the landscape. Because the bamboo grows so densely, even subtle movements of air travel through the entire grove, causing waves of motion that ripple across the tall green canopy. The bamboo itself spreads through underground rhizomes rather than seeds, allowing the forest to expand gradually outward as new shoots emerge from the soil each growing season. Over time, this growth pattern produces thick stands where older stalks stand beside newly emerging ones, creating a layered environment of varying heights and shades of green. Within this setting, the Arashiyama Bamboo Grove becomes more than a simple forest, as the interaction between light, movement, and vertical structure creates a landscape that feels both tranquil and slightly surreal. Walking through the towering bamboo columns, the ordinary scale of the surrounding world seems to fade, leaving only the quiet rhythm of the forest rising endlessly toward the sky. Farrier. On the volcanic plains of northern Iceland, Farrier unfolds as a stark geothermal field, where the ground appears stained in shades of ochre, rust, and sulfur yellow, creating a landscape that feels closer to an alien world than to the green valleys typically associated with the island. From a distance, the terrain looks almost scorched, with bare earth and mineral crusts replacing vegetation across wide stretches of steaming ground. The unusual appearance of Farir is driven by intense geothermal activity beneath the surface, where underground heat from Iceland's volcanic system warms groundwater and pushes gases upward through fractures in the earth. As this heated mixture reaches the surface, it emerges through vents in mud pools, releasing thick plumes of steam that drift constantly across the barren landscape. Sulfur compounds carried within these gases react with surrounding minerals and oxygen in the air, gradually staining the soil in bright yellow and reddish tones that give the ground its striking coloration. At the same time, bubbling mud pots form where hot water mixes with clay-rich sediments, creating pools of thick gray mud that churn slowly as trapped steam escapes from below. The constant movement of steam and gas means that the terrain here is never entirely still. As vents hiss, mud bubbles rise and burst, and the surface of the ground shifts subtly under the pressure of heat below. In certain areas, the soil becomes so hot that even small changes in geothermal flow can reshape the appearance of the mud pools and vents over time. Despite its harsh appearance, Farir is simply a surface expression of the powerful geothermal forces that define Iceland's geology, where the interaction between volcanic heat, groundwater, and mineral chemistry creates a landscape that feels almost extraterrestrial while remaining entirely shaped by the natural processes of the earth. Tulip fields. Across the low-lying countryside of the Netherlands, vast agricultural landscapes transform each spring when tulip fields bloom in long, uninterrupted bands of color that stretch across the flat terrain like painted stripes on a canvas. From above, the fields form precise rows of red, yellow, purple, and pink that extend toward the horizon, creating geometric patterns that contrast sharply with the surrounding green farmland and narrow canals. This remarkable display is the result of centuries of horticultural cultivation, during which Dutch growers refined tulip varieties and planting techniques that maximize both color intensity and uniform flowering across large fields. Because the plants are arranged in carefully measured rows, each variety blooms together in dense clusters, producing broad ribbons of color that remain visually consistent across entire sections of land. The flat geography of the Netherlands plays an important role in shaping the appearance of the fields, as the absence of hills allows the colored rows to stretch uninterrupted across the landscape. When viewed from elevated points or aerial perspectives, the fields resemble enormous brushstrokes sweeping across the countryside. Seasonal timing also contributes to the spectacle, as the blooming period typically lasts only a few weeks each year before the flowers are cut and the bulbs continue their growth cycle beneath the soil. During this brief window, millions of blossoms open simultaneously, transforming otherwise ordinary farmland into one of the most vibrant agricultural landscapes in the world. What makes the Dutch tulip fields so visually striking is not only their color, but the scale at which human cultivation has reshaped the land. Across wide stretches of countryside, agriculture and landscape design merge to create a temporary panorama where rows of flowers turn the ground itself into a living mosaic of color. Hengifoss. Rising from a steep canyon wall in eastern Iceland, Hengifoss descends in a narrow white column from high above the surrounding valley, appearing almost suspended against the dark volcanic cliffs behind it. The waterfall drops dramatically from the edge of a basalt plateau, sending a continuous ribbon of water plunging toward the rocky basin far below. What makes Hengifoss visually distinctive is the layered rock surrounding it, where thick bands of dark basalt are interrupted by striking horizontal lines of reddish sediment that run across the cliff face. These red layers were formed millions of years ago when ancient volcanic eruptions deposited basalt flows across the region, while periods of quieter geological activity allowed iron-rich sediments to accumulate between the lava layers. Over time, erosion by water and ice carved a deep canyon through this volcanic plateau, gradually exposing the alternating layers of rock that now frame the waterfall. The contrast between the dark basalt, the rust-colored strata, and the bright falling water creates a dramatic, natural pattern that is visible even from great distances across the valley. Unlike waterfalls formed primarily by soft rock erosion, Hengifoss maintains its sharp vertical drop because the surrounding basalt remains relatively resistant to weathering, preserving the height and structure of the cliff. The result is a striking geological display where volcanic history, sediment deposition, and persistent erosion combine to shape one of Iceland's most visually unusual cascades. In the red desert landscapes of Utah, Arches National Park reveals a terrain where gravity, erosion, and time have sculpted hundreds of natural stone arches rising from the sandstone plateau. From a distance, the formations appear almost improbable, with massive curves of rock suspended above open ground, as if the landscape itself had been carved into giant windows and bridges. The park contains the highest concentration of natural arches in the world, many of them formed within thick layers of sandstone that were deposited millions of years ago when this region was covered by ancient desert dunes. Over time, pressure compacted the sand into solid rock, preserving the sweeping shapes of the dunes within the stone layers that now make up the plateau. As the region slowly uplifted and weathered, cracks developed within the rock, allowing water, ice, and wind to exploit natural weaknesses along the sandstone layers. These forces gradually widen the fractures and remove softer material, leaving behind curved spans of rock where more resistant sections of sandstone remained intact. In some places, the arches stretch across large openings, creating silhouettes that appear delicate despite the enormous weight of stone balanced above them. Changes in temperature between day and night also contribute to the erosion process, as repeated expansion and contraction slowly weaken the rock and reshape the formations over time. What makes Arches National Park so remarkable is the way these natural structures combine scale and fragility, where immense masses of rock seem to hover in improbable shapes against the open sky. Each arch represents a moment in an ongoing geological process, reminding observers that even the most solid landscapes are continuously being reshaped by the forces of nature. On the Atlantic coast of Senegal, near Dakar, Lake Retba forms a striking inland lagoon whose waters often appear vivid pink against the pale sand dunes that surround the basin. From a distance, the lake's unusual color creates the impression of a landscape tinted by light rather than by water itself, especially when sunlight reflects strongly across the shallow surface. The coloration is linked to extremely high salinity within the lake, where salt concentrations can rival those of the Dead Sea and create conditions favorable for salt-tolerant microorganisms. These microscopic organisms produce pigments that interact with sunlight and give the water its characteristic pink or rose tone, particularly during dry seasons when evaporation increases mineral concentration. Because the lake lies within a closed basin with limited freshwater inflow, salt gradually accumulates as water evaporates under the region's intense heat. Over time, this process transforms the lagoon into both a distinctive natural phenomenon and an important source of salt extraction for local communities. Workers harvest salt directly from the lakebed using small boats and simple tools, gathering mineral deposits that settle beneath the shallow water and transporting them to shore in large piles that line the edge of the lake. The result is a landscape where geology, climate, and human activity intersect, turning Lake Retba into one of the most visually unusual bodies of water in West Africa. Along the coastal wetlands of Liaoning Province in northeastern China, Red Beach forms one of the most visually unusual shorelines in the world, where vast tidal flats appear covered in deep crimson vegetation rather than sand or water. From a distance, the landscape resembles an enormous red carpet stretching across the delta, its color intensifying as the marshland extends toward the horizon. The striking red tones are produced by a salt-tolerant plant known as Sueta salsa, which thrives in the alkaline soils and saline conditions of the tidal wetlands. During the growing season, the plant appears green, but as autumn approaches, its pigments gradually shift toward bright red, transforming the marsh into a continuous field of color. Because the plants grow densely across the tidal flats, their collective color creates an almost solid surface when viewed from afar, while narrow wooden walkways allow visitors to cross sections of the marsh without disturbing the fragile ecosystem. The surrounding wetlands also support migratory birds and coastal wildlife, turning the region into an important ecological habitat as well as a visually remarkable landscape. What makes Panjin's Red Beach so extraordinary is the way a single species of plant can completely redefine the appearance of an entire shoreline. Instead of waves or sand shaping the scenery, seasonal biology paints the wetlands in vivid color, creating a natural phenomenon that appears almost unreal against the muted tones of the surrounding sea and sky. Giant groundsel. High on the volcanic slopes of Mount Kilimanjaro in Tanzania, giant groundsel rises from the alpine landscape like a strange botanical relic, its tall trunk and rosette crown giving the impression of a plant more suited to another planet than to the mountains of East Africa. At first glance, the thick stems and spiky clusters of leaves resemble oversized alien flora emerging from the rocky terrain, especially when seen scattered across the misty moorlands that surround the upper slopes of the mountain. Unlike typical shrubs or trees, the giant groundsel has evolved specifically to survive the extreme conditions of high-altitude tropical environments, where temperatures can swing dramatically between warm daylight and freezing nights within a single 24-hour cycle. Its tall, woody trunk stores water and insulates the plant's core, while the dense rosette of leaves at the top helps trap warmth around the growing tip, protecting delicate tissues from nighttime frost. The leaves themselves play an additional role in survival, folding inward during colder periods to shield the central stem while releasing moisture slowly during the day, a strategy that helps the plant maintain internal stability despite intense sunlight and thin mountain air. Over time, as older leaves die and remain attached around the trunk, they form a protective layer that further reduces heat loss and shields the plant from strong alpine winds. These unusual adaptations allow the giant groundsel to thrive in an environment where many other plant species struggle to survive, creating landscapes that look more like scenes from a distant world than a tropical mountain. Spread across Kilimanjaro's high plateaus and volcanic soils, these towering plants transform the alpine zone into a surreal botanical ecosystem shaped by isolation, altitude, and the remarkable resilience of life adapting to extreme conditions. Kelimutu crater lakes. On the island of Flores in Indonesia, Kelimutu rises above the surrounding landscape as a volcanic peak known for one of the most unusual geological phenomena in Southeast Asia. At the summit lie 3 crater lakes whose waters display dramatically different colors, creating a surreal scene that appears almost impossible for a single mountain. From the rim of the volcano, the lakes can be seen resting side by side within separate craters, each basin holding water that shifts between shades of turquoise, deep blue, brown, or even reddish tones, depending on changing conditions beneath the surface. Unlike typical alpine lakes whose colors remain relatively stable, the waters of Kelimutu are known to transform over time, sometimes changing their appearance within months or years. The shifting colors are linked to volcanic gases rising through fractures beneath the crater floors, where chemical reactions occur between dissolved minerals and the surrounding water. As gases such as sulfur dioxide and other volcanic compounds interact with minerals in the lake, they alter the oxidation state of the water and gradually change its color. Each crater functions as a separate chemical system, meaning that even though the lakes sit only a short distance apart, the reactions occurring within them can produce entirely different visual results. Temperature, gas flow, and mineral concentration all influence the chemistry of the water, creating a dynamic environment where the appearance of the lakes is constantly evolving. What makes Kelimutu particularly remarkable is the clarity with which these chemical processes are expressed on the surface, turning the summit of the volcano into a visible record of volcanic activity beneath the ground. The mountain therefore becomes more than a scenic landmark, as the lakes themselves reveal an ongoing dialogue between geothermal energy, mineral chemistry, and the shifting forces within the earth. Angel Falls. Deep within the rainforests of southeastern Venezuela, Angel Falls plunges from the edge of a towering sandstone plateau, creating one of the most dramatic waterfalls ever formed on Earth. The water spills over the flat summit of Ollantaytambo, a massive tabletop mountain rising abruptly above the surrounding jungle in the remote highlands of Canaima National Park. From the moment the river reaches the cliff edge, the water drops in a nearly uninterrupted vertical descent, forming the tallest waterfall on the planet with a total height of about 979 meters. Because the fall is so immense, the descending water often breaks apart in midair, turning into drifting mist long before it can reach the rocks below. Winds moving through the canyon catch the falling spray and scatter it across the cliffs, giving the waterfall a ghost-like appearance as clouds of vapor rise from the abyss. The river that feeds the falls flows quietly across the plateau above before suddenly vanishing over the edge, where gravity transforms it into a towering white ribbon suspended against the dark rock walls. What makes Angel Falls so extraordinary is not only its height, but the landscape that surrounds it, where ancient Tepui mountains rise like isolated islands above the rainforest and create one of the most otherworldly environments on the continent. On the northeastern coast of Brazil, Jericoacoara sits between the Atlantic Ocean and an immense landscape of wind-shaped sand dunes, creating a coastal environment where desert-like terrain meets tropical sea. From afar, the region appears almost unreal, as pale dunes roll endlessly across the horizon, while narrow lagoons of clear water gather in low basins between the shifting sands. These dunes are constantly reshaped by strong coastal winds that push fine sand inland, slowly building tall ridges that migrate across the landscape over time. As seasonal rains arrive, fresh water collects in depressions between the dunes, forming temporary lagoons whose turquoise surfaces contrast sharply with the surrounding white sand. Because the dunes remain in motion, the shape and position of these lagoons change gradually each year, creating a landscape that never looks exactly the same twice. Some pools expand during wetter seasons and shrink again as evaporation returns the terrain to its dry state. The result is a coastal desert that feels both dynamic and fragile, where wind, water, and sand interact continuously to reshape the environment. Jericoacoara therefore stands as a reminder that even the most tranquil landscapes are shaped by powerful natural forces, working slowly but persistently over time. In the remote desert of northern Nevada, Fly Geyser rises from the ground like a vivid mineral sculpture, its colorful terraces and constantly flowing water creating a scene that appears almost artificial against the otherwise barren landscape. Unlike natural geysers formed entirely by underground volcanic systems, Fly Geyser emerged accidentally when geothermal drilling in the early 20th century released pressurized hot water through fractures in the ground. As mineral-rich water continued to flow from the vent, dissolved compounds such as calcium carbonate began depositing around the outlet, gradually building a mound of stone that has grown taller and more complex over time. Layers of thermophilic algae thrive in the warm water, adding bright shades of green and red that spread across the mineral surface and give the formation its striking colors. The geyser now releases streams of steaming water continuously, forming small terraces and shallow pools that spill outward across the surrounding soil. Because the mineral deposits accumulate slowly with every flow of water, the structure keeps evolving, expanding its ridges and textures year after year. What makes Fly Geyser remarkable is the combination of geological chemistry and accidental human intervention that brought it into existence. In the middle of an otherwise quiet desert, a simple well transformed into a living geothermal formation that looks more like a fragment of another planet than a feature of Nevada's dry basin landscape. Hidden within the dense tropical forests of Surigao del Sur in the southern Philippines, Hinatuan Enchanted River flows with a clarity and color so striking that the water appears almost illuminated from within. From the riverbank, the surface reveals deep shades of sapphire and turquoise, creating the impression of a pool far deeper than the surrounding landscape might suggest. The river's unusual color comes from the way sunlight penetrates the exceptionally clear water and reflects off the limestone formations beneath the surface. Because the basin connects to an underground cave system, the water remains remarkably transparent, allowing light to scatter through the depths and produce the vivid blue tones that define the river's appearance. Geologically, much of the water feeding the river emerges from subterranean springs that rise through openings in the limestone bedrock. This underground flow helps maintain a steady temperature and clarity, even as the river continues its short journey toward the nearby Philippine Sea. What makes the Hinatuan Enchanted River so remarkable is the contrast between its tranquil surface and the hidden cave network beneath it, where unseen passages channel water through the rock before it resurfaces in this luminous pool. In a quiet forest setting, the river appears almost supernatural, Yet its beauty is simply the visible expression of underground hydrology and the remarkable transparency of spring-fed water.